Hey guys, welcome to Tuesday's Notes. We are going to finish up mostly the volume chapter today and Thursday, and we'll see what we want to do then. But let's get to it. We have covered most of it. Today we're going to look at multiple step problems, which can be a little tricky. So, a little bit higher. Alright, so you can see that today we are going to look at the volume of a box, which is something you probably already know how to find the volume of. But more importantly, we're going to look at multiple step problems, which are probably the hardest kind to do because obviously they take more than one step to do. So let's get at it. Up until now, we have examined the volume formulas for cylinder, cone, and sphere. And in case you don't know them, I thought we'd put them all in one place here. The volume of a cylinder is pi times the radius squared times the height. The volume of a cone is 1/3 times pi times the radius squared times the height. And the volume of a sphere is 4/3 times pi times the radius cubed, right? Hopefully you have gotten decent at using those formulas, where if you have just one missing variable, whether it's finding the volume, or perhaps it's finding the height, or maybe it's finding the radius, if you have one missing variable, you can solve for it regardless of which one it is. Today, however, we are going to add one more figure, the rectangular prism, or more commonly known as the box. And then we're going to look at some multiple step problems. But first up, the box is pretty easy. The formula for the volume of a box is the length times the width times the height. Normally I consider this to be the length, this to be the width, and of course this to be the height. So if I wanted to find the volume of this box at the right, this one has a whopping 4 variables in it, but fortunately we know 3 of them. We know that the length is 4, we know that the width is 3, and we know the height is 6. So the volume of this box would simply be 4 times 3, which is 12, and then 12 times 6, which is 72. It'd be 72 cubic inches. All right? That's just a quick review of something I think most of you probably already knew. We are going to look at 2 multiple step problems, and these will definitely help you on your homework. So first up, let's see. Oops, I'll go that way, I guess, don't I? All right. Oh my goodness. There. All right. All right. I'm having trouble getting it all on the screen there very well. All right. Juicy Juice boxes have decided to change their packaging. They currently use a rectangular box, like this one, as shown at the right, but to save money on packaging, they are planning on switching to a cylindrical package, this one, also shown at the right. They want the volume to remain the same, so that's important. The volume is going to stay the same. And they need the height to stay the same so as to fit on the shelf, because you can only stack stuff so high on a grocery shelf. So the question is, what should the radius of the new package be? All right. So the volumes need to be equal. The height needs to be equal. The question is, what should we make the new radius of this package? so that the volume and height can be the same. All right, so the first thing we're going to do here is we're going to find the radius, the volume of the box. So the volume of the box would be the length times the width times the height, which in this case would be 15 times 6, and 15 times 6 is 90. The volume is 90 cubic inches. Okay. Let's do this. There we go. All right, so if I want the volume to be 90, I want the volume of this to be 90 cubic inches. What do I need the radius to be so that it will have that volume? So now I look at the volume of the cylinder, which is pi r squared h. And here's what I know. I know that the volume needs to be the same. So I already know the volume of this thing. It's 90. And I know pi is 3.14. I do not know the radius, but I do know the height, because they told me in the problem that the height would stay the same. So the height was 6, it's still going to be 6. So I'm putting 6 in for the height of the cylinder, I'm putting 3.14 in for pi, and I'm putting 90 in for the volume. And now I only have one variable left to solve for, which is the radius. First thing I'm going to do is I'm going to multiply the 6 times the 3.14. And when I do that, I get 18.84 times the radius squared. Now I'm going to divide both sides by 18.84. That will get the r kind of by itself. It'll get the r squared by itself. So that gives me r squared equals, and on my calculator I do 90 divided by 18.84, and I get a rather lengthy decimal, right? I get that decimal right there. Now I'm going to leave that decimal on my calculator, but I'm not going to write the whole thing down here. I'm just going to round it to maybe 4.8. My next job then is to get rid of the square. And the way I get rid of the square is to take the square root of both sides. But I want you to see how I do this on my calculator. I want to take the square root of this entire thing instead of rounding it off. So first I'm going to hit the second button and the square root button. But now instead of typing in that answer, I can hit the second button and this button, the negative sign, because that second function of that button is the previous answer, like it says above it. So I'm going to hit second, and I'm going to hit this negative sign, and now what I'm doing is I'm taking the square root of the previous answer, which is this 4.770, and I'm going to hit enter. And I get 2.1856. Let's just put 2.186. 2.186. Now, I want to round this to the nearest tenth. I don't know if it said that in the problem or not, but if it didn't, it should have. Let's see, what should the radius of the new package be? Well, I forgot to put it in there, but we're going to round this to the nearest tenth, which would make it 2.2, right? And I need the radius of the box to be 2.2 inches so that it will have the same volume. All right, let's look at one more example, which is a little bit tricky, and we'll be done. All right, this last example is A cylinder that is completely full of liquid, so this thing is completely full of liquid, is poured into a rectangular container. We're going to pour it in there. What would the height of the water in the box? What would be the height of the water in the box if all of the water from the cylinder was emptied into it? So it would appear that I have a box that has a larger volume than the cylinder. I'm going to pour the cylinder into the box, and it's not going to fill it all the way. You know, maybe it fills it up to like there. And the question is, what's the height of the water? I know the height of the box was 8 inches, but I don't really care about that. What I care about is what's the new height of the water. So here's how you would do this. First, you would find the volume of the water in the cylinder. How much water is in that cylinder? And I know that's going to be pi times the radius squared times the height of the cylinder, right? This is the volume of the cylinder. So that would be 3.14. The radius is right here. It has a radius of 2. And while I'm thinking about it, I want you to be careful, because on the homework today, which there's only 5 problems, instead of giving you the radius on a problem or 2, I think they give you the diameter. So make sure you change that into the radius instead of using the diameter. All right, and back to this, the height here is 8. This will give me the volume of the cylinder, the volume of water in the cylinder. So I do 3.14 times 2 squared times 8. And I get 100.48 cubic inches. So this is the amount of water that is being poured into the box. Now I know that the box has a volume of length times width times height. But the thing is, I don't know what the height is going to be. I mean, I know what the height of the box is, but I don't really care what the height of the box is. I care what the height of the water in the box is. So what do I know here? Well, here's what I know. I know that this is the volume that is going to be poured into the box. The volume is going to be 100.48. And I know the length of the box is over here. It's 5. And I know the width of the box is right here. It's 4. And what I don't know is it's not really the height of the box. It's the height of the water in the box. And I'll leave that as h because I do not know that. But I'm going to solve for it. So the first thing I would do is I'd multiply the 5 times the 4 and get 20 times h. And then all I need to do, of course, is divide both sides by 20, and I will have the height of the water. 100.48 divided by 20 is 5.024. And I guess that would be the exact height. If I was rounding that to the nearest tenth again, it'd be 5.0 inches, almost exactly 5 inches, 5.024. All right, I hope that helps you on the homework. Good luck, and we'll see how you do.